So you can see here in example number 3, sometimes what's going to happen here is that the coefficients are going to line up to a point where you can't just multiply one of them to create that opposite coefficient. You're actually going to have to multiply a term to both equations, and it may not necessarily be the same term. It's obviously not going to be the same term. So what we're going to end up having to do is figure out what two terms need to be multiplied so that we can create those opposite coefficients. And so if you look at example number 3, we can see that the 12 and 8 being even numbers, it'll probably be quickest and easiest to get those to line up with the same coefficient or opposite coefficients. And so in this case we pick 2 and 3, and when we multiply equation 1 by 2 and equation 2 by the number 3, we end up getting some 24s that are opposite of coefficients. And so we would go about solving this the same way as we did before using linear combination. It's just now going to take twice the effort to get the equations to offset each other. And so after we solve for one variable, we can simply plug that in and substitute into one of the two original equations and come up with our y value. And you can see here that we get a solution of 2, 3. And of course that's one of our cleanest answers that we've had so far in this set of notes. So what I'd like you to do is to go ahead and work sample problem number 3, and pause the video and work that, and then come back and take a look at the solution. Okay, if we take a look at sample problem number 3, I'm not going to have a value that I'm going to be able to multiply one term for an equation and get offset, so I'm going to have to do both. Now, unfortunately, neither one of them is very good, and so I'm going to just use an old trick that I learned back whenever I was in school. If you multiply the first equation by the bottom coefficient, so the bottom coefficient is negative 15, so I'm going to multiply the top equation by 15. So I'm going to multiply this whole thing by 15, and we'll multiply the bottom one by the top coefficient, or the first coefficient, which is 6. And so basically I've just done the exact opposite of each one of them. And so when I do that on the first one, I create some rather large numbers, which is fine because you'll have a calculator to do this. 90x minus 150y equals 180. Now, when I multiply 6 by the bottom one, I end up getting a negative 90x, a positive 150y, and a negative 180. And of course, if I stack those up, what ends up happening is the 90s cancel each other out, the 150s cancel each other out, so that's 0 on this side, and then the 180s cancel out on this side, leaving me 0 on this side. Now this kind of creates a unique circumstance. I no longer have an x value or a y value to substitute back in. I've eliminated all of my values, and so I need to look at that a little closer. Since this is a true statement, what we're basically saying is that these equations are exactly the same. And if the equations are exactly the same, that means that they share all the points on the line. And so if they share all the points, they're technically sharing all the solutions. So that means that there is an infinite number of solutions to this particular equation or system of equations. And so if you recall back from our graphing lesson, this graphically would look like the same line being graphed right on top of itself. And so infinite solutions would technically be the answer here. Now what I'd like you to do is to move on down to sample problem number 4 and look at sample problem number 4, and what I would like you to do is actually choose your method that you would like to use. So go back over the notes and see which one of the methods would work best for sample problem number 4. So go ahead and pause the video and work on that now. Okay, what I'm going to do is I'm going to suggest to you that since the first equation has a coefficient of 1 for the x value, that you would probably want to use substitution for this system of equations. That would be the route that I would choose if I was working on a test. Now, what if you didn't choose substitution? Well, that's quite alright. Linear combination would work for here just as well. So what I'm going to do is I'm actually going to work both methods for you so that you can see that they're going to come out with the same answer regardless, even though the way that they're worked may not necessarily look the same. So let's take a look at the substitution method. I'll start by changing the first equation to x equals 2y plus 3, and then I'll go through the substitution process. When I get down to this part right here, I run into a little trouble because I have 4y and a negative 4y, and of course those are simply going to cancel each other out, leaving me with this thing that says 6 equals to 7. And I simply know that this is not true. 6 does not equal to 7. This is a false statement. And since this is a false statement, what we're really figuring out with this problem is that there are no solutions that are being shared. These two lines are basically parallel, and so the answer to this would be no solutions. So that would be an example of a set of parallel lines in an algebraic form. Now, if you went the elimination route, I'll go ahead and work this from an elimination standpoint so you can see what your answer would actually look like from an elimination standpoint. So I'm going to start here. I'm going to multiply this entire first one by negative 2. And so when I do that, I end up with a negative 2x plus 4y equals negative 6. I'm just going to rewrite equation number 2, stack them up, and then cancel out, which is going to leave me 0 and then 0, and then of course on this side it's just going to give me 1. And we know that that's also a false statement, that 0 does not equal 1. And so this again is just an example of how this could come out to be no solutions. Okay, and so whether you worked it in elimination style or you worked at substitution, you should come out with the same final answer regardless. Alright, and that sums up system of equations.